more enjoyable sections. Actually, they're all enjoyable, let's be honest. I love algebra. But I do enjoy teaching this part of linear equation. So this is the first form that we are introduced to. A linear form is called slope-intercept form of a linear equation. So slope-intercept form, the form is y equals mx plus b, and it's important for us to understand what each of those variables represent. M is the slope. That represents the slope of the line. It's the rate of change. It's the rise over run from one point to the next. B represents the y-intercept. And some things that we need to know, it's where the line crosses the y-axis. It's, we'll do this, crosses the y-axis at a specific point, at a specific location. So yes, it's a number, but it's also a point. The other thing that we need to remember is the y-intercept is a point, it's a location, and it's going to be your y value is going to be or your b value. Ooh, let's do it that way. That'll be your b value, and your x value will be 0. X always equals 0 because we want to be on the y-axis. Any x value greater than 0 is going to be off of the y-axis. Any x value to the left or negative will be off the y-axis again. And here's the other tricky one a lot of people don't know. What does x and y represent? Well, x and y is equal to a coordinate. The specific relationship between those two. That's a point, and it's not just any point, it's also a solution. So it has to work. You can't just pick any x and y. It has to be a point, a x and y, where all 4 of those variables work together. Okay? Another thing, y-intercept, we talked about parallel lines, something you need to understand. Parallel lines, they're going to move at the same, they won't intersect. So in order for 2 lines to move at the same rate of change, up, right, to get to point, we use the slope. Well, if it's not going to intersect, then they have to increase and go up and right. They have to have the same slope. So same slope would produce parallel lines. So we call these parallel lines. We use that notation for parallel lines. So those are parallel lines will have the same slope. They do not intersect. Same slope. Different y-intercepts. Oh, good. Yeah, because if they had the same y-intercept, then they'd be the same line. So yes, sorry, that one little distinction. Same slope, different y-intercepts. They're going to cross the y-axis at different places. So if this is my y-axis, that would be the y-intercept for the first line. This would be the y-intercept for the second line. So that's what we're doing. Find the slope and the y-intercept. So we're going to pull out the coefficient of x, and we're going to look for the constant, and we have to solve for y. I guess I didn't do that. Y must be isolated. Isolate y, get y by itself, move everything else to the right. Okay, so y is by itself. We're going to do the coefficient of x, which is 1. So it has a slope of 1, and its constant, or the y-intercept, is going to equal -3. Y is by itself. The coefficient of x is 2, so the slope of the line is 2, and my y-intercept, again, is 3. Ooh, this is a good one. I taught you this in 8.3. We can think of this as that statement. We don't see an x, so we have a slope of 0 and a y-intercept of -2. Whoa, -2. I've isolated y's by itself. My slope is the coefficient of x, which is 1/3, and my y-intercept is 4. My y is isolated. My slope is the coefficient of x. which is negative 1/2. And my y-intercept this time is adding 0. So my y-intercept is 0. That's a little bit of a tricky one. My slope is negative 1/3. And my y-intercept is negative 3. My y is isolated. My slope is negative 2. And my y-intercept is 6. My y is isolated, so my slope is negative 4, and my y-intercept is 8. Now we should get to some tricky ones. This isn't too tricky. This is negative 1. So my slope is negative 1. My y-intercept is 5. This is poorly written. That says y equals x minus 9. So my slope is the coefficient of x, which is 1. And my y-intercept is negative 9. That's a bad negative 9. My slope is 3. And my y-intercept is negative 2. Here we go again. We have y equals, I don't have an x value, so that means I have 0 x's. We can write that. That's legit. That's a really smart way. So my slope equals 0, it has a slope of 0, and my y-intercept is 3. And that would be a horizontal line going through the y-axis at 3. Hence why my y-intercept is 3. Oh, it didn't give any. All right, so we can go back here. Here's the tricky one. X equals 4. I can't believe they didn't do that. So this is the tricky one. This is a vertical line going through the x-axis at 1, 2, 3, 4. 4, 0. And so my slope is going to be no slope. And what's my y-intercept? Here's my y-axis. Where does it cross the y-axis? It doesn't. It has no y-intercept either. So in a vertical line, it's going to have a slope of no slope and a y-intercept of no y-intercept. Different from when we have y equals negative 2. That looks like 0x minus 2. So this has a slope of 0 and a y-intercept of negative 2. This looks like, this is my x-axis, my y-axis. This is a horizontal line crossing the y-axis at negative 2. So that point is 0, negative 2, and a slope of 0. Slope of 0 is 0 over 1. It rises 0. It goes up 0 and right 1. So it goes up 0, right 1, up 0, right 1. Yeah, makes a horizontal line. So very important to know those little small differences between that. Not stated here, but it's important. So now we're going to use the slope and the y-intercept to graph the line. So let's first of all find what my slope is. My slope is 2/3, and my y-intercept is negative 4. My slope of 2/3 means, oh wow, that was really kooky. That was kind of scary. It kind of jumped me. I've been banging this board, and my little guy kind of fell on top of me. I'm surprised that didn't move either. Maybe there was an earthquake. Sorry, 2/3 slope of 2/3. We're going to go up 2 and right 3 from one point to the next. So, oh wait, I don't have a point. I can't go up 2, right 3 from one point to the next. I need a point. Do we have a point? Yes, we do. We have a point of my y-intercept. We know this line is going to cross the y-axis at negative 4. 1, 2, 3, 4. So I have a point. And now I'm going to use the I'm going to use the slope. I'm going to go up to right 3 to make another point. Up to right 3 to make another point. So very important for you to remember. Remember. Do you remember? Plot the y-intercept first. You can't use the slope because slope is from one point to the next until you have a point. So you must remember to plot the y-intercept first, then use the slope to find additional points. Very important, not stated, not told enough. Really, really important. Then we're going to connect those dots. We got to align them a little bit, align them a little bit. And then we are going to do this. And I tend to give coordinates 0, -4. And I'm going to write those coordinates next to the point. Don't write them over here. Don't put your points, your coordinates. You need to make sure that you know, that I know, that you know what that is attached to. And this would be 6, 0. 1, 2, 3, 4, 5, 6. Yeah. So we're going to put those coordinates next to the points. Good. What's my slope? My slope is 3/4. That means up 3, right 4 in slope ease. My y-intercept is going to equal -3. I'm going to find the y-intercept first. I'm going to go down 3 on the y-axis. It crosses the y-axis at -3. Then I'm going to use the slope, up 3, right 4. Takes me here. I'm going to go up 3, right 4 again. And I have 3 points. Typically, we like to graph 3 points. We're going to make arrows on that line. It doesn't want to be a segment. If you don't have arrows, then you're telling me it's a line segment. But there are an infinite number of solutions to this problem. And those solutions are 0, -3, 4, 0, and 8, 3. And if we took any of these points and plugged it into this equation, they would be true. And how many solutions are there? There's an infinite number of solutions. Anything on this line is going to be a solution. So if I plugged in this point 0, -3 into the equation y equals 3/4 x minus 3, let's plug it in. My y value is -3. My x value is 0. Does the left side simplify to make the right side? Yes, it does, and that's why it worked. Let's take a point that we didn't plot that we might be able to see. That looks like a solution too. That is -3. 1, 2, 3, 4, 5. -3, -5. Is that correct? Looks like -3, -5. Oh, sorry, that's not a solution. That's my solution. If I drew my line better, if I drew my line a little bit more accurate, sorry, I would get there. So it's actually going to be -1, 2, 3, 4. Hello. Whoa. That's going to be -4. 1, 2, 3, 4, 5, 6. -6 is that point right there. And so let's plug that in into the equation y equals 3/4 x minus 3. So does -6 equals 3/4 times -4 minus 3? Does -6 equal, these cancel to make -1, which is -3 minus 3. Does -6 equal -6? It does. Hence why that is a solution. So we can have whole number solutions or any of these points on you. That's why we're doing this. So I know that was a little bit of a tangent. Multiple tangents. Slope equals -1/2. I'm going to put the negative up in the numerator. That means it's down 1, right 2. That's going to be plus 0. My y-intercept is going to be 0. I'm going to plot my y-intercept on the origin, and then I'm going to go down 1, right 2, down 1, right 2. I'm going to connect those dots. I'm going to realign my graph so it looks relatively correct. I'm going to draw arrows, and now I'm going to label my points. I have the origin, which is 0, 0. I have a second point, which is 2, negative 1. Then I have 4, negative 2. 4 on the x, negative 2 on the y. And we're good. So a slope of negative 3/4, a y-intercept of negative 1. Let's plot my y-intercept at negative 1 on the y-axis. This is the x-axis. And now I'm going to go down 3, right 4. Down 1, 2, 3, right 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. I have 3 points. I like to do 3 points. Each teacher is going to be a little bit different on what they want to see on their graphs. Mr. Mack wants to see arrows. He wants to see coordinates 0, negative 1 next to the points. This is going to be 4, 1, 2, 3, 4, negative 4. 1, 2, 3, 4, negative 4. Yep. And this is going to be 8, negative 7. 1, 2, 3, 4, 5, 6, 7. Yep. And we're done. This has a slope of negative 1, which is negative 1 over 1, which is down 1, right 1, with a y-intercept of 3. I'm going to go to 3 on the y-axis. Then I'm going to go down 1, right 1, down 1, right 1. That's a nice, easy one. We're going to stretch those out a little bit. We're going to put arrows to show that it goes on to infinity and beyond. 1, 2, and 2, 1. Those are my 3 coordinates. Slope of 2, y-intercept of 1. Y-intercept of 1, slope of 2 is up 2, right 1, up 2, right 1. And that's what we do. We can start simplifying this and making it faster. We still want to label our points 0, 1, 1, 3, and 2, 5. Even though I didn't write the slope, which is up 2, right 1. It's always good practice. Y equals 0x minus 3. So now we're seeing that one. So it has a slope of 0, which is 0 over 1. 0 is a fraction, is 0 over 1. That means we go up 0, right 1, with a y-intercept of negative 3. So we're going to go at negative 3 on the y-axis. We're going to go up 0, right 1, up 0, right 1. And it makes a horizontal line. And we had talked about that being a horizontal line. When you only have one variable and it is y, it's going to go through the y-axis at negative 3. So 0, negative 3. That's a horrible 0 or comma. We have 1, negative 3, and we have 2, negative 3. So it doesn't matter what you plug in for x, y is always going to equal negative 3. And that's what it says. Hey, y equals negative 3. It's a statement. Y equals 5. Same thing, 0x plus 5. My slope equals 0. My y-intercept is 5. I'm going to plot my y-intercept. 1, 2, 3, 4, 5. I have a slope of 0. I can go here. I can go over here too. Still going to get me a slope of 0. Slope of 0 is a flat line. I just need to label 3 points. So that's negative 5, 0. This is 0. No, not negative 5, 0. Negative 5, negative 5, positive 5. This is 0, 5. This is 2, 5. Because it doesn't matter what I plug in for x, my y value is always going to be 5. Notice the y value is 5, the y value is 5, the y value is 5. The y value was -3, y value is -3, y value is -3. It doesn't matter what I plug in. I'm always going to get those values. Those are good tricky ones. All right, use only the slope of the y-intercept to graph this. All right, so we know that when you want to be in slope-intercept form, intercept form is in this format. Y equals mx plus b. So we have to isolate for y. So we have 2x plus y equals 4. We're going to subtract 2x from both sides. We get y equals -2x plus 4. My slope equals -2. My y-intercept equals 4. So I'm going to go 1, 2, 3, 4 on the y-axis. Then I'm going to go down 2, right 1, down 2, right 1. And we're going to do this somewhat speedy. Do you know I coached a kid named Speed? Yep, and his brother was Kaiser. Those are two unique names. But we're going to we put the arrows, 0, 4. We have 1, 2, and then we have 2, 0. Yeah. Good. Let's isolate y. So we're going to subtract 3x. These are unlike terms, so we are left with y equals -3x plus 6. We're going to put the variable x first, and then my constant. My slope is -3. My y-intercept is 6. So we're going to plot the y-intercept. 1, 2, 3, 4, 5, 6. My slope is down 3, right 1, down 3, right 1. Connect the dots. Connect the dot-ish. Good. Arrows on my line. Coordinates 0, 6, 1, 3, 2, 0. Boom. That fast. Subtract 2x. We're isolating for y. That leaves me with -y equals -2x minus 6. We need to get rid of that negative in front of the y, so we'll multiply everything by -1. That gives me y equals 2x plus 6. So my slope is 2. My y-intercept is 6. Let's go to 6. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 on the y-axis. Slope of 2 is up 2, right 1, up 2, right 1. We can connect the dots, connect the points to show all of the solutions to that equation. These are solutions to the equation 2x minus y equals -6. Put arrows. This is 0, 6. This is 1, 8. This is 2, 10. Those are all solutions to that equation. 23. I did 23 twice. I knew it was coming. I knew I made a mistake when I was doing that delete. We don't have to do 23 twice. All right, here we go. -3x, -3x. -y equals -3x plus 3. Let's multiply both sides by -1 to get rid of the negative in front of the y. That produces positive y plus 3x minus 3. We have to multiply that -1 times both of the terms on the right, which gives me a slope of 3, a y-intercept of -3. We'll go to -3. We'll use my slope of 3, up 3, right 1, up 3, right 1. Connect those dots. Oh, yes. Love when I can hit those right on it. 0, -3. That is going to be 1 on the x, 0 for the y. And then this is going to be 2 on the x and 3 on the y. There you go. Those are your 3 points. Minus x. 2y equals -x minus 2. Let's divide by 2. We have to divide everything, just like we're multiplying by -1 to everything. When we have to divide, we're going to divide everything. Did you know that negative x over 2 is equal to negative 1/2 x? Yes, that's a very important idea. Negative x over 2 is equal to negative 1x over 2, which is equal to negative 1/2 x. Very important for you to know. And notice negative 2 over 2 simplified to negative 1. So my slope is negative 1 over 2, which means down 1, right 2. And my y-intercept is negative 1. So let's do the y-intercept at negative 1. Then we're going to go down 1, right 2, down 1, right 2. We got 3 points. That was a good one. This is the point 0, negative 1. This is the point 2, negative 2. This is the point 4, negative 3. Boom. Got it. Minus 2x, minus 2x. Negative 3y equals negative 2x plus 6. Divide everything by negative 3. We get y equals positive 2/3 x. Two negatives make a positive. Minus 2. Positive 6 divided by 3 is negative 2. I have a slope of 2/3 and a y-intercept of negative 2. Let's make a point at negative 2. Let's use slope of up 2, right 3, up 2, right 3. Oh, yes. I think I might be 3 for 3 on plotting the points, or drawing the line on the points. So 0, negative 2, 3, 0, and 6, 2. Okay, we're cooking with gas right now, baby. We are just rolling through these problems. Negative 3y equals negative 4x plus 12. Let's divide everything by negative 3. That gives us y equals 4/3 x minus 4. My slope is 4/3. My y-intercept is negative 4. Go to negative 4 on the y-axis, make a dot. Then we're going to go up 4, right 3. Then we're going to go up 4 and right 3 more. And that should connect. If those points don't connect, 4 for 4. If those points don't connect, then I made a mistake. That's the easiest indicator that you have maybe made a mistake. 0, negative 4, 3, 0, and 6, 4. Yep, 6, 4. That's not a very good 6. We can connect that. That's ugly. Just rewrite it, Mr. Mac. Take a second and rewrite it legibly. Minus x, 4y equals negative x plus 4. Divide everything by 4. Y equals negative 1/4 x plus 1. It doesn't benefit me to write it as negative x over 4 because I got to find the slope. And are you able to find the slope by that? Find the slope, the coefficient. So that's why we tend to convert it and move it to negative 1 in the numerator, x in the numerator, 4 in the denominator. So my slope is negative 1/4. A little bit easier to see that information. And a y-intercept of 1. So y-intercept of 1, down 1, right 4, down 1, right 4. Well, that's pretty flat. Oh, did I? No. Okay, I broke the streak. I was on a good streak there for a little bit. I was on my graphing A game. This is going to be 0, 1. This is going to be 4, 0. This is going to be 8, negative 1. Determine whether the lines of the equations are parallel. What do we know about parallel lines? Have the same slope. Parallel lines, same slope, different y-intercepts. So it would be in our best interest to put these equations in slope-intercept form. So convert to slope-intercept form. So I'm going to write each of those in their own little column. I'm going to minus 2x minus 2x. I get negative y equals negative 2x plus 5. I'm going to divide by negative 1, divide by negative 1, divide by negative 1. Mr. Mack, earlier you multiplied by negative 1. Same thing. Same thing. I got my y to be positive. You can do that by either multiplying by negative 1 or dividing by negative 1. And that gives me 2x minus 5. I'm going to minus 2x minus 2x. I get negative y equals negative 2x plus 8. Divide by negative 1, divide by negative 1, divide by negative 1. Y equals 2x minus 8. Same slope, different y-intercepts, so we know they are parallel. They are parallel. Same slopes, different y-intercepts. They will never intersect. Let's take this equation, x minus 3y equals 2. Let's take this equation, negative 2x plus 6y equals 12. Let's subtract x. Negative 3y equals negative x plus 2. Divide by negative 3. We get y equals 1/3 x minus 2/3. Slope of 1/3, y-intercept of negative 2/3. Let's add 2x. We're getting y by itself. We're putting it in slope-intercept form, which is y equals mx plus b. So we have the same slope, different y-intercepts. So lines are parallel. Same slope, different y-intercepts. Let's write the starting equations. 2x minus y equals 6. 2y minus x equals 6. Look at you, you little trickster. Minus 2x. Minus 2x. Negative y equals negative 2x plus 6. Divide by negative 1. We get y equals 2x minus 6. We're going to add x to both sides. Did you see that? 2y equals x plus 6. Divide by 2, divide by 2, divide by 2. Y equals 1/2 x plus 3. Oh, they have different slopes and different y-intercepts. Doesn't matter about y-intercepts at that point. Not parallel. They're not parallel. They will definitely intersect. They have different slopes and different y-intercepts. That doesn't matter about the y-intercepts once the slopes. That only matters, y-intercepts only matter if they have the same slopes. Because if they have the same slope, same y-intercept, then they're going to be the same line. They will not be parallel because there'll only be one line. Parallel lines are two lines. So these are not parallel. They will intersect, is what we're saying. 3x minus y equals 2. Negative 6x plus 2y equals 8. Minus 3x minus 3x. Negative y equals negative 3x plus 2. Divide by negative 1. Y equals 3x minus 2. Add 6x, add 6x. 2y equals 6x plus 8. Divide by 2, divide by 2, divide by 2. Y equals 3x plus 4. Kind of wish that they gave us one with the same slope and the same y-intercept. That would have been fun. So same slope, different y-intercept, lines are parallel. Same slope, different y-intercepts. Last one. Ooh, ooh, two more. It's 5:01. On a Wednesday, I want to go home. 1/2 x minus 1/2 y equals 4. 2x minus 2y equals 3. So let's move the x. We get negative 1/2 y equals negative 1/2 x plus 4. How do we get rid of a fraction? We're not going to divide. We're going to multiply by the reciprocal, which is negative 2. And we're going to multiply everything by negative 2. So this is where it's good practice for you. Negative 1/2 times negative 2 is positive x minus 2. Minus 2x minus 2x. Negative 2y equals negative 2x plus 3. Divide by negative 2. Divide by negative 2. Divide by negative 2. Y equals x minus 3/2. So, same slope, different y-intercepts. So, lines are parallel. Same slope, 1 and 1. Different y-intercepts, negative 2, negative 3/2. Last one for the day. 4x plus 1/4 y equals 2. 4x plus 4y equals 2. Minus 4x. Minus 4x. 1/4 y equals negative 4x plus 2. Multiply by the reciprocal, which is 4. Distribute it to both of them. Y equals negative 16x plus 8. That's a big slope. Minus 4x minus 4x. 4y equals negative 4x plus 2. Divide by 4. Divide by positive 4, Mr. Mac. Y equals negative x plus 1/2. These lines have different slopes and different y-intercepts. Doesn't matter if about the intercepts. So they are not parallel. They will intersect. Different slopes. That's negative 1, negative 16. Yes. Let's go home, shall we? What a day. We are almost April 17th. We're getting close to graduation time. 26 more school days. Good luck. Prep for that placement test.